Frequency tables.
All right, geometry. This is going to be your last week of video lessons for the 2019-2020 year. We got 2 videos, 2 lessons. This is going to be covering frequency tables, as it says there. This one's a pretty easy one here. Really what it's about is creating a graphic that would help you do something called conditional probability. Well, a small part of conditional probability is not the main aspects to it. What it is really good for is statistics, okay? You might end up taking that later when you go to college, or maybe even when you're in high school here, you'll probably need to take it. Well, you'll probably need to take it in college, but you might take it in high school. That's how I should have said all that. Anyway, it's a super easy thing here. All right, let's see, frequency tables. Basically, it's a chart. It might as well be an Excel chart where you just have a lot of data that's filled in there. And if you add up all the values in a row, there's going to be a total column at the end of it. Like these 2 things are going to add up to give you the 257. These are going to add to give you that. These add to give you that. And you can also add things vertical. All right, these 2 add together to give you that number, add together to give you that. So it's like a spreadsheet is basically all it is. But given that spreadsheet, you're able to look for percentages, and percentages are one of the things that we use in probability. Anyhow, here, a 2-way frequency table, which is pretty much what you end up looking at on things here. It displays frequencies. Frequencies are the amount of time something appears, a quantity of something, how frequently something has happened. Okay, something vaguely stated that way. Okay, a 2-way frequency table displays the frequencies of data in 2 different categories. Okay, so example number 1, what we have here is a table that has 2 categories, as mentioned above. You've got male and female. Then you've also got extracurricular activities. You've got involved in activities or not involved in activities. Okay, so what I was about to say a minute ago, but wouldn't have made sense until I pointed to something here, is that usually in these, the most common type thing that you see is your categories. So this is gender and this is extracurricular activities. Those are your categories. That a category will be broken into 2 things, like yes or no sort of thing. Okay, what do you call binary sort of thing. So you're either male or you're female. Now I know you might want to debate that for a second, but let's not get into all those aspects there. Okay, so male or female. Okay, extracurricular activities, you're either in them or you're not in them, right? So you only have one or the other sort of thing that's available there. Later, we're going to look at some tables where maybe you have a few different choices, but they all still come from the same category. All right, so what we're looking at here is the 112 are going to represent the males. I didn't read any of the problem here. That a randomly chosen student is, okay, I don't want to read the question yet. Okay, but these are randomly chosen students. The 112 is going to represent male students that are involved in activities. The 145 are going to be male students who are not involved in activities. 139 is female involved. 120 is female not involved. Okay, and then when you look at these totals, the 257 is the total of the males. This is going to be the total of the females. This would be the total of students involved in activities. This would be the total of students not involved. So can you guess what that number means? Well, it's either when you add all the males and the females together, or it's when you add all the students involved and all the students not involved. They both end up with the same number, which would be the total number of students that we have. Okay, so here's our question that we're going to answer. Now, talking about that's a lot more than actually answering the problems here. What is the probability? And we're going to think of that as a percentage. We'll start with a fraction, then I'll change into percentage. What is the probability that a randomly chosen student is a female? Okay, now if we only stop there, said is a female, that would be 259 out of 516. But we want a female who is not involved in extracurricular activities. Only those females, the 120. Okay. Chosen student is a female who is not involved in extracurricular activities. So that's going to be 120 out of 516. You got to be really careful about reading these because there's other ways that you can word them. You could say, like if I read the question what is the probability a female student is not involved in extracurricular activities? And it sounds very close to, but I said, what is the probability that a female student is not involved in extracurricular activities? That means your pool of students is only from the 259. So that would have been the denominator. But it leaves it to the chance that you're choosing a male or a female in the way it's set. So what's the probability that a randomly chosen student is female and also involved? So we're choosing from all 516. But there's ways that you can word these a little bit differently, and you want to be careful that you get your denominators correctly. I haven't looked at these examples in a little while, so hopefully that'll show up somewhere. Okay. So as an answer, that's all right. I don't even know if I want to bother with like reducing these things here. I'm just going to go ahead and type them in. And we end up with about 0.232 blah, 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 which we can call 23 point, I was going to watch that number, 23.3%. Yeah, a little bit of rounding there. I usually make, not usually, I'm guilty of making mistakes with rounding, so I got to really think about it. Goes there, looking at the 2, the 5's enough to knock that up to a 3. Okay, so that's the answer to the first one. All right, next, not much of a different thing that we're doing here. We just have these tables that are called relative frequencies. Okay, anytime you actually hear the word relative, it means that we're thinking of stuff as a percentage. However, most of the time, the percentage is represented as a decimal. So if you take a look at the table here that we've got, it's a different topic. I don't know if these are people who attended a seminar or did not. Okay, so you either attended the seminar or you did not attend the seminar. You're either going to have increased sales or you're going to have no increased sales. So it's your sales versus whether you went to the seminar for that stuff. Okay, but when you look at all the numbers here, these are all just decimals. So basically what they did to get all of these is they took the 4 numbers that would have been in the middle, right there, none of the total numbers. Those you get by adding stuff a little bit later here if you want. Okay, but really taking these 4 numbers and dividing them by this, because all 4 of these are going to eventually add up to give you that. I hope you see that in the way that we add across the sides and down, and then those totals become that these 4 here account for everybody that's involved, and they have to make that grand total of 516. So if you divide each of these by that number, then you end up getting, you get your decimal numbers. Likewise, you can take the totals and you can divide those by the big number that's here and you'll get a decimal, or you could just add the decimals you get. Now I should probably start pointing at the other picture here, because you can add these 2 together and get that number. You can add these 2 together, get that number, and then you can add and get that number. Okay, what's interesting here is that the very last one is going to be a 1. That represents 100%. Okay, now as far as, you should be able to see that the numbers add up to get you there. But if you think about all the rest of them were created by dividing by the total number, if you divide the total number by itself, you're going to get 1. You get 100% from that. Okay. So in this table, you don't actually know any raw numbers. You don't know how many people went to this seminar or not. You just, these are the percentages. It might have been 100 people, it might have been 1,000 people. We don't know what it would be, but we do have percentages here. All right, for the example, what is the probability that someone who attended the seminar had an increase in sales? What is the probability that someone who attended the seminar had an increase in sales? Okay, so this gets a little bit tricky. The way that it's worded here, it's not taken from the whole. What is the probability that someone who attended the seminar? So we're choosing from that group. You've got to choose from that one. It's not, what is the problem that we randomly select someone who did go to the seminar and had increase in sales? We're saying, what is the probability that someone who attended it had increased sales? I'm trying to emphasize things as much as I can. I don't know if that helps. But it means that we're only looking in this column here. We don't care about people who didn't go. The wording of it tells us that we need to look in this part here. Okay, so we want increase in sales. That means we're going to take the 0.48, and that's going to get divided by the 0.8. Now, these might look a little bit unusual because they're not raw numbers here. It seems like we're already taking percentages and now we're dividing percentages, and that's true. Okay, but remember, if you were to if we knew the number of people who actually attended the seminar, you could multiply every number by that one and it would look just like the problem that we were doing beforehand. Okay, so you take the numbers that you get. Let's see here. This one should be an easy number, 48 divided by 8, right? But let's just type it in. 0.48 divided by 0.8 is going to give us 0.6. Okay, and then as a percentage, because we probably want our probabilities percent, that is going to be 60%. Now, let's take a little glance at the numbers here. That 0.48 is a little bit bigger than 0.32, so having something that's a little bit more than 50% sounds reasonable. Okay. So keep in mind here, relative frequencies are they're the percent versions of all the numbers. But the way that you do the calculations is still going to be like what we see in example 1. Okay, you're looking for your numerator, the group they're interested in, out of the total that we have to choose from. All right, I got one more here for you. The table looks larger, doesn't it? But it's still going to be a two-way table because you only have two categories that we're looking at. We're looking at ages over here. So these are age brackets that we've got, which has 1, 2, 3, 4. It has 4 different little brackets you can have here, but the category is just an age, the different ages that we're looking at. And then you've got these options here. You got for, against, or no opinions. This had to do with an opinion on a state bill. We don't need to know what it was, but they're either for it or against it, or they don't really care. Those are your options. So you do have more like subcategories and things, but you actually have 2 large categories that you're just matching up: ages and opinion. That's it, ages and opinion. All right, let's see here. So all 3 of these will add to give you that number. All 3 of these will add to give you that number. 1, 2, 3, 4, all those will add to give you that number. And if you were to add up, I don't want to actually draw on here, but if you can see all of the boxes that are not on the right or the bottom, which would be 12 of them there. These 12 boxes in the middle should all add up to 1,000. What a convenient number too, right? Okay, what is the probability that a randomly selected person is over 60 years old given, here's the key part, given that the person had no opinion on the state bill? Okay, so again, they're not asking the question, what is the probability that a randomly selected person is over 60 and that they had no opinion? If they said it that way, that they were 60 and had no opinion, that would mean, over 60, that would mean that you take the 40 out of 1,000. But the wording here in here changes it just a little bit. Given that the person had no opinion on the state bill. So that means we only look here. They must have no opinion to be part of this. So what is the probability that a person in that category is over 60? And that's going to be 40 right here out of the total for that column, which is 100. And that, of course, I don't even know why I even thought about that for a second, is 40%. Given that. Now, out of all the people over 60, no opinion is that 4%? Is going to be 4% of all the numbers. But given that category there, I do want to mention one other thing, because this example and the last example both used a vertical column. You can say problems different ways that you have a horizontal column. Like I could reword this one, and the answer ends up being totally different, by the way. But I could reword this. Let's see if I can do it on the spot. What is the probability that a randomly selected person has no opinion given that they're over 60? What is the probability that a randomly selected person has no opinion given they're over 60? And if I asked it that way, I'd be looking at this row and now dividing the 40 by 210, and you get a totally different answer for that one. Okay, so maybe The most challenging thing that you're going to have here is the wording, but pay very close attention to it. I've tried to emphasize it here that in some cases you're looking out of all, and in some cases we're trying to limit the row or column that we're using to answer the question.